Day 204 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 204 and we're still going strong, y'all. Right now we're in the middle of the top 150 interview questions from LeetCode. So if you have an interview coming up or you're doing these LeetCode problems just to practice for an interview that you may get in the future, you come to this channel at the right time, y'all. We're doing the interview questions, so get excited about that. And if you've been following this channel the whole time, congratulations. We made it to day 204 and we're still going strong without any signs of slowing down. So before we get started today though, y'all, don't forget, if you need any new Apple AirPods, go ahead and check out that link in the description. Then after you check that link out in the description, go ahead, bring a mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we could push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow. And one way we can do that is to share this content out with as many people as we can find that will watch it. So your support is appreciated when it comes to that, y'all. Now, with all that being said, let's get into the question. And today we have question number 30, substring with concatenation of all words. The difficulty level is hard, but don't worry, y'all. We're going to keep the solution as simple and easy to understand because I understand that we're all on different levels of our programming journey. And so we all need to learn. We need a solution that everybody can understand, right? So that's why we're going to keep the solution as simple and easy to understand because we want everybody to feel included and be able to understand the solution at the end of this video. Now, with all that being said, let's get into the question and see what the question says. And the question says, you are given a string S and an array of strings words. All the strings of words are of the same length. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. For example, if words equals AB, or if words equals an array of strings, first string AB, second string CD, third string EF, then AB, CD, EF, AB, EF, CD, CD, AB, EF, CD, EF, AB, EF, AB, CD, and EF, CD, AB are all concatenated strings. ACDBEF is not a concatenated string because it is not the concatenation of any permutation of words. Return an array of the starting indices of the concatenated substrings in S so you can return the answer in any order. So let's break that down. So in example 1, we have the input S. Input S equals bar foo, the foo bar man. And words are just foo. It's an array of strings, foo and bar, right? And the output is 0, 9. So you might wonder, how do we get 0, 9 from these strings? So let's look at the explanation so they can break it down for us, right? So the substring starting at 0 is bar foo. It is the concatenation of bar and foo, which is a permutation of words. The substring starting at 9 is foo bar. It is the concatenation of foo bar, which is a permutation of words. So we have this input S, and we have words. This also input words, which is an array of strings, right? We want to find the concatenations of these 2 words that are in words, the array of strings, and we want to return the index where those concatenations start, right? So in this example, we see right here, we have one concatenation that starts at 0, right? We have bar foo right here. That's a concatenation of foo bar. So we can see that, remember, because it says in any permutation, meaning these words can be in any order. And in this case, the bar just comes first, but it still counts as a concatenation, right? So we have bar foo. So if you notice that this concatenation starts at index 0. So that's why we put a 0 right here. So let's keep going. Let's count the indexes till we get to 9, and you'll see that 9 will be another concatenation, right? So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom. So when we get to 9, now you see we have foo bar. Foo bar is also a concatenation of the words foo and bar, right? So that's why we put a 9 right there, because it starts at index 9. So the first concatenation starts at index 0. The second concatenation starts at index 9. And those are the only concatenations in this input S string, right? So that's why we only return 0 and 9, because those are the two indexes where the concatenations start. So let's look at example 2, where it's a little bit more words and it might be a little tricky. And in this case, as you can see, there are no valid concatenations. So let's go through it and see. It says in example 2, we have the input S equals a string. It says word, good, 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 best, word. The words equals an array of strings, word, good, best, and word. Output is a blank string. It says there are no concatenated substrings, right? So with the concatenated substrings, we need all of these words to be included in the concatenation. So you might say we have word right here, we have good right here, but then you notice the next word will be good. That's no good. That's no good, because there are not two goods in this array. There's two words, but there's not two goods. So the moment we see word and then we see two goods in a concatenation, that does not conclude every word in word, so we know that's not word. It doesn't work right like that. Then you might see good, best, and word, and once again you notice down here we have two words, so that's not going to work either. We have a word right here and we have a word right here. But if we try to use this as a concatenation, you will see it only has one word, so it doesn't count because we need two words. So that's just an example of why this output is a blank array, because there's no concatenation of all of these words in the input S. So let's look at example 3, where input S is a little longer, but it's like example 1, but we added the word the, and the input S is a little longer. So let's see. So the output, or let's go through it from the top. We got input S equals a string, and it's bar foo foo bar the foo bar man. Words equals an array of strings, bar foo and the. The output is 6, 9, and 12. Let's look at the explanation. Explanation says the substring starting at 6 is foo bar and the. It is concatenation of foo bar and the. Right. So let's check it. Let's check the work. Make sure it checks out. So we have 0, 1, 2, 3, 4, 5, 6. So the concatenation starts right here. We have foo, bar, and the. Those include, this concatenation includes every word in words, which is why it's a good. It counts, right? So we put a 6 right here because it started at index 6. So let's go into index 9 right here. We have bar, the, foo. That started at index 9. That includes all of the words in words, so it's a good concatenation. Let's see what the explanation says. The substring starting at 9 is bar the foo. It is the concatenation of bar the and foo, right? So bar the foo has all the words. It's in any permutation, but that just means we can arrange these words in any order as long as all of these words are there. And right here at index 9, we find a concatenation where all of these words are there, so we know it's good. Boom. So now we have 12. Let's see what 12 is. Starting at 12, we have the, foo, and bar. That is another concatenation. It includes all of the words. We have the right here, foo right here, and bar right here. Explanation says the substring starting at 12 is the foo bar. It is the concatenation of the foo bar. So those are the only concatenations in this string that include every word in words, and these are the indexes that those concatenations starts at, 6, 9, and 12. So that's how the question works. That's what the question is asking. Now that we understand the question, let's get into the fun part, the part that all keeps us motivated to keep going in the morning, the actual code, y'all. The code's not that difficult. It's a little lengthy. It's not too lengthy, but you know how these hard problems be. But we'll get through it, y'all. So let's do it like it's nothing to it. First thing we're gonna do is we are going to declare a constant called let. No, we're going to declare a constant by saying, called letters count, by saying let letters count equal words dot first, put the exclamation point because it's optional, and we'll dot count. We're going to come underneath that. We're going to say let declare another constant called total count. We're going to say let total count equal letters count times words dot count. Come underneath that another constant called s array. We're going to say let s array. This is where you guessed it, we're going to turn s into array. By doing that, we're going to say let s array equal array, open up the parentheses s. That's going to turn s into an array of characters so that we can mutate them. Then we are going to come down here. We're going to declare a variable called words dict. Set that equal to a dictionary. So we're going to say equal dictionary, excuse my spelling. Then we're going to innet, open up the parentheses, words dot map, open up the brackets. We're going to say $0. This is going to represent each word in words, comma, 1. It's going to create a tuple, or sort of like a dictionary of, it's going to create a dictionary with the words. We're going to start the count at 1. We're going to come outside that bracket. We'll say comma. Then we're going to say unique keys with colon 1. So not 1 plus. So what that is going to do is it's going to add 1 of every time we see a word, and it's going to basically keep track of, or it's going to keep count, of every word that we see. So if we see a word twice, then this 1 will turn into a 2. So we see a word 3 times, then this 1 will turn into a 3. You know what I'm saying? And this 0 is going to represent the word, so we know which word has which count. Then after that, we're going to come underneath that, declare a variable called result, and we're going to set that equal to a set of integers, like so. Boom. Then we're going to come underneath that. We're going to start our for loop. We're going to say for k in 0 up to letters count, open up the brackets. We're going to declare a variable called left end for left index, set that equal to k. Declare another variable called right end, set that equal to k plus, open up the parentheses, letters count minus 1. Then we're going to come underneath that, declare another variable called counter. We're going to set that equal to words dot count, and another variable called dict. We're going to set that equal to words dict that we created up here. Then we're going to come underneath that. We're going to say while right end is less than s array dot count. What we are going to do, we're going to open up the brackets. We're going to say let current string equal a string, open up the parentheses, s array, open up the square brackets, right end minus, open up the parentheses, letters count minus 1. Come outside of those parentheses, we're going to say dot 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 right end. Boom, just like that. Then we're going to come underneath that. We're going to say if let count equals dict, open up the square brackets, current string, come outside the square brackets, comma, count is greater than 0. We're going to open up the brackets. We're going to say counter minus equals 1. Then we're going to come underneath that if statement, and we are going to say dict, open up the square brackets, current string, comma, default is 0, and we are going to say minus equals 1. Come outside the square brackets, say minus equals 1. Then we're going to come underneath that. We're going to say while counter is equal to 0. Boom. Open up the square brackets. We're going to say let distance equals, open up the parentheses, right end minus, should be minus left end. Boom. Then we're going to come underneath that and we are going to say if distance equal signs, open up the parentheses, total count minus 1, come outside of those parentheses, open up the bracket, we're going to say result dot, not append, we're going to insert, open up the parentheses, and we're going to say left end. Then we're going to come underneath that and we are going to say let left string equal string, open up the parentheses, we're going to say S array, open up the square brackets, left end, dot, 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 open up the parentheses, left end, plus, open up the parentheses again, letters count minus 1. Then we are going to come underneath that and we are going to say if let count equals dict, open up the square brackets, left string, come outside the square brackets, comma, count equal 0. I'm going to open up some brackets. We're going to say counter plus equals 1. Then we're going to come underneath that if let, and we are going to say dict square bracket left string, comma, default 0. That should be a 0, y'all. That should be a 0. Come outside of that plus equals 1. Then we're going to come underneath that. We're going to say left end plus equals letters count. Then we're going to come underneath that, come outside of this while loop, but still inside this while loop, we are going to say right end plus equals letters count. Then we're just going to come all the way right here, boom, outside of this for loop, all the way right here, we're going to say return array, open up the parentheses, result, because we had to turn result into an array. Now let's run it, y'all. Let's run it. That should be all she wrote. Let's see if we can get this first try. Oh, okay. No, we cannot. So let's see where we went wrong, right? What does it say? Consecutive statements must be separated by a line. Let's see. It's all in line 6. So hopefully we could fix line 6 and we could go on about our merry little way. You know what I'm saying? So let's see where we went. Oh, I'm sorry, y'all. This right here should be in parentheses like that, right? Because we got to make it a tuple. So let's run it again. See if it runs this time. Okay, so we still incorrect label, unique keys with expected underscore somewhere. So let's see, what did we do wrong here? So I spell unique keys with, it should be I don't even know how to say this. Unit queuing. It should be unit queuing keys with, not unique keys with. So let's run it again. See what happens. Okay, we're getting somewhere, y'all. We're getting somewhere. We're not there yet, though. Let's see. Give me this. Maybe this should be a capital. Let's run it again. Let's see. Y'all know the syntax. You know how it gets with the syntax. But there it is, y'all. It's accepted now, so let's run it. Make sure it stays accepted because we all know how these LeetCode problems get. Could never be too sure. But look at that, y'all. 162 milliseconds beats 65.82% of users with Swift, y'all. Not too bad. Not too bad at all. That's what I like to see. And you know what else I like to see? I like to see y'all here tomorrow for another day, another LeetCode problem. But I almost forgot, y'all. Before we go, get one more look at the code. One more look at the code. I know it's a lot, so let's give everybody a chance to get one more look at the code before we leave for the day. We'll be back tomorrow. Don't worry, don't worry. Get one more look at it. One more look at it. Let's make sure y'all get everything y'all need to get some of this good stuff, get some of this good code, y'all. Get some of this good code, and like I said earlier, I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.